Static electricity. Transfer of charge. How they behave. Laws of static electricity. When materials gain or lose electrons on rubbing, static electricity is generated. Some materials hold their electrons very tightly, so it is difficult to generate static electricity using them. Other materials have some loosely held electrons which move through them very easily. We can use such materials to create static electricity. How can we move electrons from one place to another? One very common way is to rub two objects together. If they are made of different materials and one has loosely held electrons, then the electrons may be moved from one substance to the other. So you know that some atoms develop positive charges and some atoms develop negative charges. Positive and negatively charged atoms behave in interesting ways. Did you ever hear the saying that opposites attract? Well, it's true. Two things with opposite or different charges, a positive and a negative, will attract or pull towards each other. And what happens when you bring two objects with the same kind of charge close to each other? They push each other away or repel each other. It's quite easy to do an experiment and verify this. Let's do it. Rub a glass rod with a silk cloth. That gives the glass rod a certain charge. Now, we will balance the rod so that it can move freely. Now, we are going to rub another glass rod with a silk cloth. So, the second glass rod has the same kind of charge as the first. Now, let's bring them together and see what happens. They are pushing each other away. That means they are repelling. So, there we have the first law of static electricity. Like charges or charges of the same kind repel each other or push each other away. We state the first law of static electricity then. Like charges repel each other. Did you understand the first law? Let us move on to the second one. Now, let us keep that first charged glass rod. We will rub a different rod, an ebonite rod with a woolen cloth. An ebonite rod rubbed with a woolen cloth has a charge that is opposite to that of a glass rod rubbed with a silk cloth. Let us bring that ebonite rod close to the glass rod and see what happens. The glass rod gets attracted to the ebonite rod. Well, that tells us the second law of static electricity. Opposite charges or charges of different kinds attract each other or move towards each other. We state the second law of static electricity then. Opposite charges attract each other. But what if you bring an object that is not charged at all near an object that is charged? That means we are going to bring a neutral object close to a charged object and see what happens. This is a charged rod and we balance it so it can move. Then we bring a rod that is not charged close to it. They both look the same, but you know that one is charged and one is not. Bring them close and see what happens. The charged rod is attracted to the neutral rod, and it can be any neutral object. It doesn't have to be a neutral object of the same material. Any charged object will attract a neutral object. We have a charged object which is the rod and a neutral object which is the bottle. The charged rod will attract the bottle, as you can see. Let's try one more thing. Here, we will balance this meter stick, which is made of wood. It is a neutral object. We are going to balance it. Then let us bring a charged object, which is the rod, close to it. And what happens? The charged object attracts the neutral object, as you can see. The charged object even attracts our finger, which is neutral. So we know one more thing about static electricity now. A body that is charged attracts a body that is not charged. We can state that a charged body attracts a neutral body. Well, what happens when a body with no charge is brought near a body with charge? You know that in a neutral atom, the number of electrons is equal to the number of protons. In a neutral body, all the atoms are neutral. So the total positive charge is equal to the total negative charge. Now, when a charged body is brought close to it, we will consider a positively charged body first. If a positively charged body is brought close to the neutral body, what will happen is something like this. The negative particles in the body will get attracted towards the positively charged body and will gather at the side of the object that is towards the positively charged object. This is because opposite charges attract. The positive particles in the body will gather towards the opposite side. That is because like charges repel. So, an opposite charge develops on the end nearest the charged body and a like charge develops at the farthest end. This is known as electrical induction. What happens when the charged body is removed? The charges at two ends of the body mix together again. So there is no charge on the body. The body remains charged only as long as another charged object is placed nearby. From this you can also see that the attraction between a charged body and an uncharged body is because of an induced opposite charge. Using this information, can you explain why our hair stands up when we take off a wool hat? Well, when you take off a wool hat, it rubs against your hair. Electrons move from your hair to the hat. Each hair on your head gets the same positive charge. Remember, things with the same charge repel each other. So each hair will try to move away from the others as far as possible. The farthest they can get is by standing up and away from the others. And that is how static electricity causes a bad hair day. See what happens to hair when it is charged with static electricity. And what happens when you walk across a carpet and touch a doorknob? As you walk across a carpet, electrons move from the rug to you. Now you have extra electrons and a negative static charge. Touch a doorknob and zap! The electrons jump from you to the knob and you feel the static shock. What did we just learn? In a neutral body, the number of positive charges and negative charges is equal. When a positively charged body is brought near an electrically neutral object, negative charges gather on the side of the object closer to the charged object. The positive charges gather on the other side of the neutral object. This action of electric charges, which takes place when two bodies are brought close together, is called electrical induction. When the charged body is removed, the charges at the two ends of the neutral body mix together and no charge remains on it. The attraction between a charged and uncharged body is due to the induced opposite charge.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.